Hey guys, this is AS Physics Errors and Uncertainties. There are two forms of errors that you need to know. Absolute error, which is when we're dealing with addition or subtraction, and percentage errors when we're dealing with multiplication and division. You will find percentage errors more in your exam compared to absolute errors, so I'm going to focus more on percentage. Let's start with absolute errors. First of all, what is an error? You can see that I have this measurement here. Let's say that I took some measurement from my ruler and this is what I get. I get x as my measurement, and then I write a plus and minus sign, and after that I write my error. And with that error you would always find a unit beside that error. You can also define this error as a triangle or delta. Errors always add up between each other. You would not subtract, you would not multiply, you would not divide errors between each other. You would simply add them up. Let's say that I have A, and in A the measurement I took was 2, and the error in that measurement was 0.2 centimeter. And in B I took my measurement as 3 with the error being 0.3 centimeter. And I have been asked to add A plus B. So to do that, first of all, you're going to simply, they've said that add A and B. So I will first add my measurements, which is 2. And I would simply do 2 plus 3, which gives me 5. And after that, you would add up those errors. And to add those error up, I would call this delta. And delta would be equal to the error in A plus the error in B. And the error in A is 0.2. The error in B is 0.3. So 0.2 plus 0.3 would give me 0.5. And 0.5 is going to be my error. So the final answer for A plus B would be 5 plus or minus 0.5. Let's do this one, 3A plus 2B. First of all, what is A? What is the measurement of A? A was 2, right? You can see that A is 2. So I'm going to simply first add all those measurements. 3 times 2 plus 2 times B. And you can see that B is 3. So 2 times 3. And that would give me a measurement of 12. So my final measurement of this equation is 12. How do I solve the errors? To solve the errors, I would simply do this. 3 times the error of A, which is 0.2, plus 2 times the error in B, and the error in B is 0.3. So in the bracket I'm going to write 0.3, and I get my final answer as 1.2. Now you would notice that I said earlier that errors always add up between each other, and you can see that error is multiplying by 3, and that is also true because I've said that errors will add up. So the error in A plus the error in B. So I get my final answer as 12 plus or minus 1.2. Let's do this final absolute error, which is A minus B. I will first solve the measurement ones, which is 2 minus B being 3, and I get my final measurement as negative 1. Now, how do I solve for errors? I told you earlier that errors will add up with each other. They would not subtract. So instead of doing 0.2 minus 0.3, I would do 0.2 plus 0.3, which gives me my final answer as 0.5. and this would equal to -1 plus or minus 0.5. Now, when should we use percentage uncertainty? We use percentage uncertainty when we are multiplying or dividing any two values between each other. Let's say that they asked me to do A times B. Would I use percentage uncertainty or percentage error? I would, because I am multiplying these two values. Now, let's say they asked me to find 3A minus 4B. Would I use percentage error or uncertainty here? I wouldn't. Why? Because it's the values A and B are not multiplying or dividing, they are simply being subtracted by each other. If the values were to multiply with a variable like 3 is a variable, then that would not mean I would use percentage uncertainty. So this is wrong. Let's say I was asked to find 3A times B. Would I use percentage uncertainty? I would, because A is being multiplied by B. There is a formula for finding the percentage uncertainty, and the formula is the error over the value times 100. So let's say that my A was 2 plus or minus 0.2. Now I would put 0.2 instead of my error, and I would put 2 instead of my value. Times 100 would give me the percentage uncertainty in A. Even if we are multiplying the values between each other, percentage uncertainty will always add up. I will explain this later. Constants are ignored when solving for percentage uncertainty. Let's say I was finding 3A times B. When I will find percentage uncertainty, I will simply ignore this 3. Let's do this question, A times B. And will I use percentage uncertainty or absolute uncertainty? I would use percentage. Why? Because I'm multiplying A with B. So step one is to use the percentage uncertainty formula to find the percentage uncertainty in A and in B. That would be the error in A. So the percentage uncertainty of A would be 0.2 over the value or the measurement of A, which was 2, times 100 would give me 10%. Now, I told you earlier that I would add both percentage uncertainties. So I will find the percentage uncertainty of B and then I would add it with A. Percentage uncertainty of B would be the error in B, which is 0.3, over the value in B, which is 3, times 100. That equals 10% as well. Now I add the percentage uncertainty of A with percentage uncertainty of B, and I get my final percentage uncertainty as 20%. Step 3 is to multiply the percentage uncertainty with the algebraic result of the values. So what does this mean? It means that whatever A times B in the value or the measurement gives me, I would simply multiply that with the percentage uncertainty. So 2 times the measurement in B, which is 3, gives me 6. I will now multiply 6 with the percentage uncertainty I got from adding percentage A with percentage B. So 6 times 20% gives me 1.2. This is going to be my absolute uncertainty. So my final answer would be the result of my measurement, which is 6 plus minus the error that I get, which is 1.2. Let's do this one. 3A times B. First of all, let's find the value. 3 times 2 times, what is b? B is 3. So 3 times 2 times 3, I get 18. For the second step, I would find the percentage uncertainty, the total percentage uncertainty in this algebraic sum by adding the percentage uncertainty of A plus the percentage uncertainty of B. So percentage uncertainty of A would add up with percentage uncertainty of B. We will only ignore constants when adding the percentage uncertainties. So when I'm adding the percentage uncertainty, I would not consider this 3. We will not ignore any constants when dealing with values. So when I solve my 3a times b for the measurement or the value, which was a was 2 and b was 3, I did consider this 3. I did not ignore it because we will only ignore it when we are adding the percentage uncertainties. So percentage uncertainty of A I calculated earlier was 10%, and in B it was 10% as well. So I get my final answer as 20%. Now what was the next step? The next step was to multiply the measurement or the value with the percentage uncertainty I get from this answer. And 18 times 20% would give me 3.6. So I get my final answer as 18, which was the value that I got from 3a times b. So I write 18 plus or minus the error which I get from multiplying that value with my percentage uncertainty in A and B, which was 20%. So 20% of 18 was 3.6. So I write my error as 3.6. Let's do one more. Pi a times b square. So first of all, I would solve for the values or the measurements, which was 2 and 3. Pi times a, which was 2, times b, which was 3, and this is squared, so I'm going to put a square. And I get my final answer as 56. Next, I would find the percentage uncertainty in A and then find the percentage uncertainty in B and add both of those percentage uncertainties. Let's first find percentage uncertainty in A, which was 10%. I would add this with the percentage uncertainty of B, which was 10% as well. But there's an extra step because this B has a square. When something has a power, I would multiply its percentage uncertainty with that power. So in this case, I have 2 as my power, so I'll multiply B. I would multiply the percentage uncertainty in B with 2. So 2 times the percentage uncertainty of B. I get my final percentage uncertainty as 30%. Finally, I would multiply this 30% with 56. So 30% of 56 equals 16.8. And that is my error. My final answer would therefore be 56 plus minus the error, which was 16.8. Let's do this exam question. The stress, let's call this S, in the wire is calculated by using S equals 4F over pi times d square. Show that the value of S is this much. To solve this, I would simply replace F and D with the values that they have, which is 0.4 and 25. But this 0.4 is in millimeters, and I want to convert this into meters. Why? So 4 times F, which is 25, I would not change 25 into any other unit because it's already in newtons, over pi times 0.4 times 10 to the power of negative 3 to to convert this millimeter into meter, and then this whole thing is squared. So I will square this. And when I solve this, I should get 1.99 times 10 to the power of 8. Let's do the second part, which says determine the percentage uncertainty in S. The percentage uncertainty in S would be equal to the percentage uncertainty in all the variables I have here. So I have F, I have D, I have pi, and I have 4. I will ignore this 4 and this pi. Why? Because they are constants. So ignoring 4 and pi, the percentage uncertainty in S would be equal to the percentage uncertainty in F plus 2 times the percentage uncertainty of D. I'm multiplying this D with 2 because this D has a square. So percentage F would equal to 0.5, or the error in F over the value which F has, which is 25 times 100, plus 2 times the percentage uncertainty in D, which will equal to 0.02 over the value that D has, which is 0.4. When I'm solving percentage uncertainties, I will ignore any units. I will not convert this 0.4 millimeter into meters. Times 100, and I get my answer as 12%. So sigma or S has percentage uncertainty of 12%.